YC Mathematics and Physics, University Calculus, Lesson 12, Implicit Differentiation. Let's consider a function. Y equals 3x squared plus 5x. We know how to find the derivative. We learned this before. So what is y prime? Y prime is 2 times 3 is 6, 6x plus 5. That's the derivative. So this function is given such that the variable y is on the left-hand side. But sometimes the left-hand side contains both y and x. So suppose if the given function is not like that, if the given function is that we have say y is minus 3x minus 5x equals 0. If this is the given function, so how do we do that? How do we find the derivative? Let's move this, let's move these two terms to the right-hand side. So we need to rewrite it, okay? So rewrite. The first step is to rewrite. So rewrite this given function. You move the x terms to the right-hand side. And then we do the derivative. So it's 6x plus 5. So the first step is to move the x terms to the right-hand side so that the left-hand side you have only y. But sometimes this is not easy to do. For example, but if the function is, but if given this function, y power 5 if this is the given function, then we cannot solve this. Then so we cannot solve for y. We cannot solve for y, which means we cannot find y is equal to all the x's on the right-hand side. This is not possible. Then what do we do? Then in this case, what do we do? Then we just do the derivative, do differentiate, then just term by term. So let's do the differentiation of this, 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 and this. So do each term. So if we do each term, so this is what we get. Let's label this equation A. Now we have the question, why the derivative of this is this? Why the derivative of y to the power 5 is 5y. Why? Why is this so? Then we need to go back to previous lessons. Because we have the general power rule. Which is lesson 4. What is the general power rule? The general power rule says for this function, u is a function of x. So if the function is given in this form, then the derivative is times. The derivative is this part is a power rule, followed by the derivative of u. Actually, this is called a chain rule. Okay, this is our general power rule. Now, let's see if we let u is equal to y, then what do we have now? Then we have f of x is y to the power n. And then just follow the general power rule. The derivative is n y n minus 1 times y prime. So this follows from our general power rule when the u is just y. Then you see, in our case, we want to find what is the derivative y to the power 5. So in this case, y to the power 5, and then the derivative of y to the power 5 follow this rule is 5 here, y, 5 minus 1, and then y prime. So that's why that explains why the derivative of y to the power 5 is this. So which is this? And this also explains why the derivative of y cubed is this. Similarly, the derivative of y cubed is is this. Then we can continue from equation A now. So let's repeat. Let's copy, rewrite, just repeat. Repeat our question A, our equation A. So we just rewrite it. Okay. Three y squared y prime minus 6x minus 5 equals 0. You see y prime here, factor y prime. So I have 5y to the power 4 plus 3y squared. Factor the y prime here. And let me move 6x and 5 to the right-hand side. Once we have this, we can find the y prime now. Therefore, y prime is and this is our answer for the derivative of this function. This function, this given function, because we cannot solve for y, we cannot find the y on the left-hand side and or the x on the right-hand side. We cannot do this. Then we just do term by term, find the derivative, term by term, and we get this result. So in general, the result will contain both x and y. You see the right-hand side, we have both x and y. This is the general result. When we find the derivative this way, we do derivative term by term, and we do not need to solve for y. If we do this way, it is called implicit differentiation. Yes, implicit differentiation. Good. Let's have more examples of implicit differentiation. Okay. Let's have another example. Ax to the power 6 plus 2x, 6 power 3y minus y to the power 7, x is equal to 10. Find y prime. So we do implicit differentiation. So the derivative of this, so what is the derivative of this? It's a and times 6. So a times the derivative of this, which is 6x to the power 5. What is the derivative of this? Now you see that this is a product. You have two functions. The first function is x cubed. The next function is y. So you have a product. And this is a constant multiple. So we don't need to bother with the 2. And we do the product rule of this. The product rule says the derivative of this, which is 3x squared, u prime v is my y, plus v prime u, v prime is y prime, times u is x cubed. So that's this part. Then we do this. This is also a product. So I have minus product. U prime v, u prime v, u prime is 7y times y. This is our general power rule. So u prime v plus v prime u. V prime is this derivative. This is just 1, so I have equals the derivative of 10, which is just 0. So this is our derivative, term by term. And this method is called implicit differentiation. The next step is just to rearrange the terms and simplify your writing. So I have 6ax to the power 5 plus 2 times 3 is 6. And the 2 multiply into it. Minus this 7. I write x first, x and y to the power 6, and then y prime. Minus plus is minus, and then y to the power 7. Now, like what we have before, we need to collect, or we need to factor out y prime. So I have y prime here, so let me factor it out. Okay, so 6ax5 so factor out y prime. I have 2x cubed minus 7xy prime minus y to the power 7. And let me move the terms without y prime to the right-hand side. So move this to the right-hand side, right-hand side, right-hand side. And I have y prime right-hand side, so I have, this becomes plus when I move it to the right-hand side. And this term becomes negative, this term becomes negative. And this bracket is the denominator, right? That's it. That's our answer now. Notice that the answer contains both x and y. Okay, so this is another example. So we have two examples in implicit differentiation. And I think you can do some practice questions. Okay, here I'll give you some practice questions. Okay. So here, I have question 1, 2, 3, 4, and so on. This is the question part, and this is the answer part. So I'm not sure whether you can copy the whole thing because I have many more there. So I give you 5 here, so 5 or 6, see, 1, 2, 3, 4, 5, 6, until 6. And then I move the paper so I can let you see from 7 to 12. So you need to copy these down and practice and check your answer against the answer I gave you. Yeah, you can pause your video and copy this down. Good. This is the end of our lesson 12. Yeah, this is end of our lesson 12. As before, I write down my telephone number in case you want to discuss anything. So this is a telephone number. And my name is Fan. Okay? So call me this number. Thank you for watching. See you next time.